Okay, so the next part, as I promised, is going to be about intellectual foundation. Because what I claim that if you learn Ruby on Rails or even Python or C++, you're actually not going to have any intellectual foundation whatsoever. You're just going to know how to write sort of strange incantations. So here I have a rather unpopular point of view. I actually claim that programming is a mathematical discipline. And it's very unpopular among all kinds of people. It's very unpopular if I give a talk, and I did in computer science departments. Why is it unpopular? Because you see they spent this enormous effort escaping from Department of Mathematics. And here comes the guy and tells them, well, guys, it's a mathematical discipline. They say, no, no. We have a different way of thinking, not mathematical. And if they do, let them go away. They actually have nothing to contribute from my point of view. That is, I actually believe the foundation of any science is mathematics. And in our case, we literally do not have anything but mathematics. What do? We operate with abstract things. Guys, we operate with these true, false, these are abstract things. They do not exist. They're not like this desk. They're not like this chair. They're not even like this glass. We represent reality in terms of some abstract entities. That was the fundamental breakthrough of mathematics, which goes back to Pythagoras. Again, the idea that everything in the world could be expressed through numbers. Yes? And computer science or programming, since I don't really believe in computer science as a discipline, which is such a dreadful thing to say, the programming made this wonderful step from numbers. It went even one more step to binary numbers, to those wonderful things called bits. There is this amazing thing which we as a discipline proved, that everything in the world, whether it's art, whether it's music, could be represented as a sequence of bits. By the way, it's true, I could show you. I mean, I have this little device in my pocket which represents both art and music as a sequence of bits. Right? It's a wonderful, great discovery. Again, we talked even the last lecture about bits not being invented by some hackers. Bits were invented by a great philosopher, Leibniz. He was the person who first intuitively understood that sort of reduction of the world into bits is a wonderful, wonderful thing. We will get to that. So I claim that we're a mathematical discipline. Now, here I have to be careful. Does it mean that you should abandon whatever you do and study algebraic topology? No, I actually don't say that. However wonderful algebraic topology might be, you do not need to study it probably for the rest of your life. Elementary number theory is another story. But what I want to say is that, sadly enough, we all, when we get out of school, we go to college, we go to some junior university across the road, we get out of there, even with advanced degrees, without actually knowing much mathematics. It's very, very possible. Moreover, it is basically inevitable because math is not taught. You say, oh, but I took calculus. That's what I mean. Math is not taught. Calculus, at least the way it is taught now, is hardly could be called mathematics. It's a bunch of recipes which they present so that you could pass undergraduate physics course. Sort of a simple way of putting it. Mathematics is important. And I do not believe you could be a good programmer without solid mathematical education. This is not I mean, those of you who know me know that that's what I believe. I say it in my lectures, I say it in my books, I say it everywhere. So what do you do? Where do you start? And there is, fortunately, a very easy starting point, which I will sort of indicate. Some of you heard, many of you heard of it. Again, the thing which you should start with is elementary algebra. You say, oh, I know it. Oh, do you? Are you really fluent with continued fractions? Do you know Lagrange's theorem about continued fractions? How many of you do? Okay, exactly my point. This is the stuff which was taught in elementary algebra before new math came. Right? We have right now worldwide math illiteracy, which happened because elementary algebra was replaced with what goes under the name of set theory, which is not set theory, it's just, Venn diagram sort of thing. But people do not know mathematics. And my advice, this is practical advice, actionable advice, that you should seriously invest in learning basic algebra. Why? Because believe it or not, what we do daily is elementary algebra. We manipulate x and y's. We manipulate simple integral quantities. You have to learn this stuff. Where do you go? Again, as I have been telling some of you might remember, there is a great textbook. We have been around right now for over 100 years. It was written by George Crystal. He was a very distinguished mathematician, student of Maxwell. And I do not mean my dog. I do have a dog called Maxwell. But it's available on Amazon. It's the only edition you should get is the edition published by American Mathematical Society. There are multiple cheap versions, but they're very bad. You cannot see what it is. It's 2 heavy volumes. It's not going to be an easy thing. But let me tell you, if somebody tells you that there is an easy path, he will lie. Most of you are pretty intelligent, so you already know very basic things. What you need is to build a better foundation. So as a better foundation, my firm advice to everyone, and I know it's difficult. Some people tried, like Ryan Ernst, who is not with us anymore. 4.5 years ago, when I came to A9, we talked, and I said, he said, I want to be a great computer scientist. I say, great, go. He said, what do I read? I say, start with Crystal. And he started and worked through about 40 pages out of about 1,000. It's hard. You have to do it every day. You have to get, Jack knows the story. Jack also thought that he might want to do it. But finding time is always hard. So again, I insist, this is one of the things which I think that it will do any programmer great good to go through this course. It contains elementary number theory. It contains wonderful treatment of continued fractions, which are very important for sort of computation, even if you want to sort of do good, simple numeric libraries. It's very good to know what they are. It has a wonderful introduction to elementary probability theory. It has all kind of solid stuff. People used to teach in high school. This was a text used in public schools in England. Of course, you have to realize that the word public school in England means Eton and Harrow and so on. So places where simple people like us are not supposed to send their children. So, but at least this stuff was taught. It's possible to teach children this stuff. So you do stand a chance. You don't need any preliminary knowledge to read it. Again, this starts from very simple sort of treatment, of things like a plus b squared. But it is a remarkable book, and it's full of exercises, problems. So in order to really successfully study it, you have to do problems. All of my courses here fail. Why? People don't do homework. If you don't do homework, however brilliant the lectures or the book or whatever, you're not going to learn. You have to do problems, okay? Whatever you study. If you want to study a foreign language, whatever you study. If you want to learn the piano, is it enough to read a book? No, it's not. It goes with everything. So study is hard, but let me tell you good news. This I learned from my personal experience. Study is an acquired habit. That is, if you start reading Crystal and you persevere for a while, it will become a pleasure. All right? For example, I had a great friend, John Wilkinson, very close friend of mine, Paul. Paul knew him. Sadly, he died a few years back, which was rather bad for me. I don't know about him, but I lost a very close friend. So he was a mathematician, but what he did, unlike most mathematicians, unlike most of us, he acquired a great habit of study. He would wake up every morning at 6 o'clock and spend from 6 to 8, 2 hours, studying some mathematical book. Right? Or studying a foreign language. Again, not reading books, but studying. And he acquired this lifelong habit of study. He couldn't live without studying. It became a habit. It's like, when you're a child, you really don't want to brush your teeth. Your mother has to come and say, did you remember? At some point, your mother had to say, and you would try not to, but your mother would catch you. It happened to me. And, but I cannot imagine not brushing my teeth now. It became a habit. Or taking a shower, or things like that. We acquire habits. And study could become a habit. And I urge you to acquire this habit. And it's not important whether you do 2 hours like John, or do half an hour. For most of us, habit becomes watching television. That's a habit which is known as, technically, as what? A vice. And evil habits, A good habit, what are they called? Virtue. Bad habits, they're called vices. So watching television, which is it's like smoking pot. It destroys your brain, except worse. So, I'm serious. And all of us acquire this habit. We come home. I know people who say, I cannot eat without television on. This is clearly biologically not true. But it happens. People could be trained. And we have to train ourselves. I'm sorry to use these words, but we have to train ourselves for virtue, not for vice. We have to train ourselves to read Crystal, not Harry Potter. So, again, yes?
Wasn't it your friend Lincoln who said that in his experience, those without any vices generally had no virtues as well?
I don't know this saying, but I believe that in the following sense. You have to struggle. All of us have to struggle with vices. Yes, obviously. If we don't have vices in that sense, we're not human. But we have to fight them. And what we don't naturally have are virtues. And we have to struggle to acquire them. Right? It's a struggle. We have to struggle. It's again this what I'm trying to send you a message that in order to acquire fluency in programming, you need basic mathematics, and for that you have to exercise. It's like building your muscles. Right? So I recommended one book, and I would recommend the other one, which is less obvious. But there is a plentiful historical evidence that we should read it. And I mean Euclid. Again, people always ask me, but I never deal with triangles. Yeah, I grant you that. You probably don't deal with anything at all if, you just write stuff. But why is Euclid important? These are not the individual theorems, however beautiful they might be. Euclid demonstrates in a remarkable way, in a better way than any other book ever written, this beautiful organization of knowledge. You see, Euclid has a brilliant plan. Some people even know what the plan is. What's the plan? What is he trying to do? Is it just a bunch of, nobody knows. Huh? You went to school, but you never know. That's the results of modern education too. Huh? So he had a great plan. Greeks, long time ago, before Euclid, even probably Pythagoras, or at least early Pythagoreans, discovered there were some amazing things called regular polyhedra. They observed that there are these amazing things which have these beautiful symmetries, things like a cube or tetrahedron. And then what they discovered is that there are only 5 of them, only 5. This is a remarkable fact. Like polygons, we could have as many as we like. Well, maybe not if we use ruler and compass, but that's another thing. I don't want to go into that direction. But they discovered that there is some limitation. There is some, and this is very important sort of fundamental intuition. You could have only so many of some things. So in some sense, you could view this long thing, which Euclid does, as leading to one thing, proving that there are only 5 regular polyhedra, right? And showing how to construct all of them with ruler and compass. Of course, there's beautiful things. There are some asides, like beautiful aside and number theory, but they're all sort of related. There's great panoramic plan, which is never taught anymore. Nobody knows. You could go and get PhD in Berkeley in mathematics, and unless you take a course taught by Robin Hartshorne, Berkeley is really good. It's the only place in the world where for a while there was a course on Euclid taught. And do you still go to Berkeley? Yeah. They still teach it, not by Hartshorne, but by, I think, Vera Serganova teaches it now. Take it. You have an opportunity. It's free for you. Whatever, it's almost free, yes. So you have this wonderful, wonderful opportunity. So I do urge people to do that, because what do we do as programmers? We build large systems, right? So in some sense, creating a balanced structure, creating something beautiful with the beginning and the end, that's our goal. And I claim that working on Euclid, again, there is 2 remarkable books. First of all, there's a great translation with commentaries of Euclid by Sir Thomas Heath, which you could acquire all 3 volumes of it for about $35 on Amazon. You heard of Amazon. It's published by Dover. If you want to buy an edition from Dover, 3 volumes. There are very many fakes, because nowadays you could have your own published from my basement publishing house. And since it's out of copyright, people do not buy those. There's Create Space Publishing House, which, if, I'm against capital punishment, but there should be some exceptions. Dover, it's very cheap, it's easily available, and there is a remarkable book by Robin Hartshorne of Berkeley called Euclid and Beyond, which explains Euclid to modern idiots like us, because we no longer could understand. So, remarkable book. I tend not to recommend modern books often, but that's a good one. So I urge you to build mathematical preparation. Say, what else? Do I need to know other things to be a good programmer? Yes, yes.
Does the Crystal book have solutions to problems?
Yes, it does. It has solutions in the following. It has like a short, like for example, compute this, it will give you the answer. So if it's a proof, no. Okay, but mostly yes, it does. It's a canonical old-fashioned textbook. You could use it in a sense. It's written in Victorian English. So, but if you could read Dickens, you should be able to read Crystal. And you should read Dickens, by the way. So, somebody disagrees? Wrong.
No, there's one copy of the textbook
Oh.
on Amazon.
One copy?
Yeah, it's about to be backward.
Crystal from AMS? Did you check from AMS? Okay, so if you buy it, you will get it. And then it will be back-ordered and arrive from the publisher. The publisher exists, right? Sort of, by the way, I have been advocating this book for at least 20 years in public, so this is not new. And I'm probably responsible for more sales on Amazon of Crystal than any person alive. And I don't get any commission, by the way, guys. There is no.
There's no limit. Freely available. It is available.
From AMS, check. Guys, offline. I'm not going to discuss Amazon warehouse fulfillment centers and other things. I'm not competent. So I do recommend that. So what else should you study? And some of you remember that I highly recommended few books on programming. Again, basically do not read any language books, whether it's Python, C++, Java. Do you need to know programming languages? Yes, as little as possible. That is, in any programming language, you should write in the smallest subset possible. Right? There are people who want to use the most advanced features of C++ 14. Desist. Try to write as close to C as possible. Right? Are closer to C than C. Sort of, it should be tiny, tiny language. Yes?
So there's a little bit of a conflict because you're always saying no one knows the standard library of.
You need to know algorithms. That's a different thing. You don't need to know C++ standard library. You need to know about rotate, whether you implement it yourself or take it from the standard library. Again, I insist that a programmer must know algorithms and data structures, but not algorithms and data structures in Python or C++. There is no such thing. Right? You should know how algorithms work. Then you need to be able to implement them in a given language and do it well. No question about that. But right now we have it backwards. We have these people raving about all the problems will be solved if we switch to Scala. I don't believe it. Why? I heard these things for the last 40 years. There's some bunch of crazy people running around. Oh, if we switch to Algol 68, you probably never heard, but I remember that was a hot thing when I was, remember that, Paul? EPL1 before that I do not remember. He is a year older than I am. So. Well, plus in Europe, nobody took PL1 seriously. They did Algol 68, which for a while was the dominant unimplemented programming language. It was so cool, but there was no compiler. And then there was Alphard. People were coming and saying, oh, you just wait. We're still waiting. There was this guy, guys at CMU, Bill Wolf and company who designed this ultimate programming language called Alphard. Truly beautiful, predecessor of everything. They never bothered to implement it. It's really well designed, but why do you need a compiler? So, and then there was Clue, and then there was MacLisp, ZetaLisp, Interlisp. Do I have to go? Scheme, T. I could go through all these bunch. And then there was Prolog. There was even a major, at that time, what was the major industrial power? Not the United States. The United States was dead. Everything was Japanese. Japan was taking over the world and buying Manhattan and Columbia Records and whatever. And Japanese government declared that the future of the world was Prolog. Logic Prolog. You do not remember that. You were not born. But we remember that. It was did it solve any problems? Well, I mean, it solved some problems with people who got grants. But, no, it didn't solve any problems. And then there was Ada. Anyone remembers Ada? Solved problems for me. 2 cars. I bought 2 cars out of Ada grants. I was a poor assistant professor. It was a big deal. So, useless stuff. No, but, I mean, it disappeared. But they solved the problem with another great programming language, Ada 95. Remember Ada 95? How many of you programmed in Ada 95? Huh? The government spent $1 billion to solving programming problems. Huh? So languages come and go. And then there is D. And there will be, what is after D? E, F, whatever. There are many, F. Yes. So, guys, it's not about programming languages. I have been talking about it in the course, but I want to emphasize it at the end. It's not about, because it's simple solution. And Swift, I forgot Swift. It was. But again, this is fashionable stuff. This is Harry Potter of the programming world. So what should you do? You should stick to Knuth. Again, I recommended some other books. I recommended Dijkstra's Discipline of Programming. I recommended Wirth's books. They're still great. But there is this great book called Knuth, which we should all sort of use. You should learn to use Knuth. It's an effort. It's not an easy book to learn to use. But there are lots of useful stuff there. So you have to acquire this thing. And the third thing, so mathematics, algorithms. And the third part of your sort of knowledge should be you should know the hardware. Longer we progress, less we know hardware. Paul and I were fortunate. We had to program in machine language. We had no choice. Right? Even like in case of Paul, he was one of the early compiler people who was implementing, APL and, Snowball and other ancient languages, by the way, at Berkeley, together with Nerd in Space. He and Charles Simoni, he was the best friend of Charles Simoni because before Charles started marrying Swedish countesses. He does too, I'm not making it up. So, but he doesn't program. If you marry Swedish countesses, you don't need to. But we knew the machine. Like in case of Paul, he was very fortunate. He did a lot of early programming on 6600, a great computer designed by, anybody knows? By the greatest computer architect. Who is the greatest computer architect of all times? Cray, yes, Seymour Cray, who designed Control Data 6600, a beautiful machine, in many respects a predecessor of RISC, as it's a long discussion, but sort of learning architecture, learning several architectures is very good. It was wonderful for me that before I got to any programming languages, I became fluent in at least 3 different computer architectures. I knew every instruction in my sleep, as it were. Now we have a generation of you who never saw an instruction. Truly speaking, when I came to A9, one of the first projects I wanted to do required assembly language. And, the bunch of guys, remember Ryan, who was one of them, they was, assembly language? I mean, what's assembly language? You never saw an assembly language. But it was very good for us to go, for example, Anil there and Dan Rose, my other collaborator, and I did the following thing. I don't know whether Anil remembers, but we went through entire Intel manual looking at instructions, one after another, sort of saying what could be done. And we will just say, oh, that's a useless instruction. That's a useless instruction. But we found good things. Right? The machine is your friend. Get to know it. You have to start with at least sort of periodically rereading the recent edition of Hennessy and Patterson. That should become a habit. And fortunately, they update it. Sadly enough, let me warn you, they entirely ignore Intel. And they still live in the world. Their RISC is something interesting. RISC is dead. I mean, it's just factually true. You have to learn Intel. I cannot recommend any book which deals Intel. Sadly enough, it's, by the way, let me tell you something which is very unfashionable. Intel is a great company. They started with a sort of instruction set which was a dead end when they designed it. They, against all the pundits, and I was one of them, everybody was saying, this instruction set is dead. It cannot survive. We were all wrong. They were able to evolve the architecture. They discovered things which didn't know about, I don't want to give a talk on unaligned reads and writes, but they did some fantastic things which nobody foresaw. There is some engineers there who are really, really good. So did I say good things about Intel? Yes. Now let's say bad things about Intel. They, as a company, they absolutely do not, I wish Attilini is out, so whomever is in charge of Intel would listen to it. They have to somehow produce books which would allow programmers to read their stuff. They, hire Patterson. They cannot hire Hennessy. He is, next thing he will be the president of the United States. You just watch. You know who Hennessy is, yeah? President of Stanford. Yes. Great guy, great guy. He's the only guy who was able to be a computer science department chair at Stanford without making any enemies. It's impossible for department chair not to make enemies because they make most important decisions, office allocation. All right, and it's really important. So he managed to be, and then as a dean, he continued. He's sort of, I attended many meetings with him, and he could make any conflict into sort of kumbaya. I don't know. That's sort of wonderful, wonderful set of skills. So Hennessy for president. So I don't think you could write this book, but we do need, so there I have to leave you on your own. You need to know architecture, but you have to center on Intel architecture because most likely that's the machine which will run your code. You have to know it. And we have shameful ignorance. For example, I was talking to someone from A9 3 days ago, and I mentioned SIMD instructions, and the answer was, what's SIMD? You have to know, guys. I repeat, the hardware is your friend. Finally, the final part is, what is my dream? And my dream, of course, is a dream. It, most likely will never come true. But some of you, those of you who sort of followed these many courses I taught here, know one thing for granted. Whatever, I might be a good lecturer, bad lecturer, good computer scientist, bad computer scientist. I love programming. I truly love programming. In the sense, if I'm in a bad mood, if I'm very depressed, everybody who works with me, they say, oh, let's write some code. And I could just, I love writing code. I think it's a wonderful, wonderful thing. But I actually claim, this is here I'm going, that right now everybody says programming is junk, some trivial stuff. All kind of computer science people say, oh, there is computer science and there is programming. We don't care about programming. Truly they don't. Very few professors could write any code. Programming is wonderful first, but it's not just a hobby. It's not like playing Sudoku or whatever you guys play nowadays. I think it's truly a fundamental thing. We are changing the world. Programmers, not computer scientists, but programmers, yeah. I mean, we're changing the world. We're sort of radically changing it. And it's a great privilege and responsibility. So let me talk about that. I claim that since we're so very important, we have to do something about it. We have to, for example, we have to be at least, you're going to laugh, but I don't mean it, to become as good as lawyers. Not that lawyers, they're a butt of jokes, and rightly so. But nevertheless, they are, what are lawyers? A profession. There is this great thing of being a profession. Right? And what distinguishes profession from being working at a bar? That's not a profession, everybody would agree. I mean, it could be a great bartender. That's not really a profession. So what makes a profession? By the way, historically, there was these things which were professions. And the first professions, 3 professions were medicine is one, yes. Law, clergy. There were 3 things in universities traditionally you could study. You cannot just, in California, you could become clergy by paying $50. It used to be impossible, still impossible, fortunately, in Germany. They regulate. You have to go and get, advanced degree from accredited university. Right? And there is an assumption, so what does notion of profession entail? First, it entails certain area of study, including abstract subjects. Again, think about medicine. They don't just say, give him aspirin. They make you learn how the body works. It's literally start with physiology. They have to memorize. You cannot be a doctor without memorizing. Huge number of bones. And you say, why do they need it? They need it because they believe that's the right study. All right? Every lawyer, or at least used to be, it's still technically true, but every lawyer in English-speaking countries, in countries based on English common law, that's on which the United States legal system is based, had to read which book? What was their Euclid? Did they have a Euclid? Yes. Blackstone Commentaries. It's a great text by 18th century British legal scholar, which is still in print, which is still a great book to read if you want to understand English common law. It's called Blackstone Commentaries. And every lawyer had to work through this scholarly text. That was the basis. It wasn't like, but I don't need it to defend this rapist. Yeah, you actually don't. But you have to understand the legal system, its nature, before you could defend. Right? It's not the bloodstains, which was the basis of the law. It was this fundamental study. By the way, after American independence, what do founding fathers do? One of their first sort of private action. They say, guys, let us collect some money to publish Blackstone. They collected money, and by the way, if you ever come up with this edition on some garage sale, buy it and give it to me. So it's a wonderful thing to have. But by the way, highly recommended. If you want to sort of learn about society where you live, Blackstone is a good start. Another good book to read is, of course, Alexis de Tocqueville, Democracy in America, a great study of American political system, but written by Frenchmen, in French. So, great book nevertheless. Now, to become a profession, what do we need? We need this intellectual foundation. That is, we need our professional canon. Everything we agree that it's like Blackstone. We will all read these books. We'll all read Knuth. Right? We have to stop being, in some sense, you know, could you imagine walking into some programmer's office and see a guy in a clown pants? Say yes. Yeah, sure, no problem. Could you imagine entering Stanford Hospital and seeing a sergeant in clown pants? No, they do not do it. They're professionals. If you go see lawyers, they're even worse. They wear suits and ties. Again, there are some professional appearance, some professional norms, even as far as the time, which we're totally lost. We have to look at Nick. Joking. I know. Plus the bananas. Just think about what. But what I am seriously concerned is that what we need, and this comes with what makes a profession, a bunch of established ethical norms. Right? That we have to develop, and there are a bunch of things we have to learn. For example, compared with doctors, very few doctors would come, no problem, I'll do it in 3 days. Do I have to explain why I'm giving this example? Sort of, we as a profession become totally careless about over-promising and under-delivering. We lost, think about, we're building world infrastructure. In some sense, even damage to people's health we could inflict is far greater than doctors. And if nobody is watching us, in some sense, good. We could inflict all this damage while nobody is watching. But maybe we should wake up. You see, we are so very powerful. We could do much good, but we could do much evil. And so far, we haven't evolved into a profession. Right? I'm not saying we're bad people. We mix, like lawyers. There are some evil lawyers, there are some good lawyers. Same thing. But we are not making an effort, and this is my dream. I really hope, I will not see it. I might not see much longer anything, but for sure I will not see emergence of programming as a profession. But I really want you, younger people, Jack over there, to eventually become a professional. He would walk around Mountain View with his head raised high and feeling good because he is a programmer. We should be proud. You shouldn't be dreaming every day that maybe you could become a product manager or engineering manager or director or whatever. Being a programmer should be a wonderful thing. Right? There should be satisfaction, should be being a good programmer. Right? Which again, sort of right now it's all corrupted with these enormous venture capitalist funds. And you cannot become a profession when they give you free bananas and T-shirts and a huge number of options. You see a guy who says, well, by 30 you have to retire to Hawaii. Why become a professional? Most sergeants do not aspire to retire at 30. Yeah, my age, yes, but you have to first work. So again, my dream and my hope is that you will sort of live to see it and also contribute to this future. Because, the interesting thing about the future is we actually make it. Sort of every little step, sort of even reading crystal could bring this future closer. You say, well, who am I? You're a human being. We are part of this process of building the future, and we could do a little bit too to make it the way. And I'm just sharing my thoughts about this future. Thank you, guys.